To construct our platformer, we will need a platform class. Now the platform class is going to, it won't have an update, it will have a display. It has our standard X and Y values with it. You can copy paste from an existing class, or you can just make a new one. So I'm going to make my platform file. In here I'll just do class platform, curly brace, go down and close my curly, go up. And my platform will have an X, it will have a Y, and it will have a width, and it will have a height, because those are the values that it needs. And now to construct it, we of course say platform, throw a couple parentheses in, and then we need to figure out X is going to be equal to something, Y is going to be equal to something, width is going to be equal to, all of our platforms can be the same size, or we can pass values in when we make them. Doesn't really matter. I'm just going to say all platforms are 200 wide, and they all have a height of 20. Now this X and Y, this is troubling because we don't know where it's going to be. But I want to be able to use this class multiple times because I want to have multiple platforms. So that means when we construct it, it's kind of like making a particle where we then give it a value when we make it. I suppose the other option is we could construct it and then we could set its location. So we could give it a set start location similar to what we did to the bullet. And we could put that in. But there's no reason not just to put it in the constructor because that kind of fits with it. So we will start it out and say float. And I'll just reuse start X and float start Y. So my X is now equal to start X. My Y will be equal to start Y. That's our constructor for the class. Now we need a display method so we can actually see this platform. And for that, we can just choose a fill color. I'm just going to choose red. Now, if you had an image, you could display an image here if you're using artwork instead of computer-generated stuff. And now I'll just draw a rectangle at X, Y, width, and height. And that really is all we need to do to have our platform class. Then we can add the platform to our project. We can set the display for the platform. Then we can check intersections with the platform. All kinds of good fun as we work our way forward. Jumping over to our main class. This is where we get to now start adding in our stuff. So I'm going to add in my platform. I'll just call it P. No use, trying to be fancy with my naming. I'll stick with the same kind of thing I'm using. And then I'll say P is equal to a new platform. And I'll choose my starting values. And to fit with this artwork, giving it an X of 300 and a Y of 500 fits. It puts it in a location that the player is able to interact with decently. Now the platform doesn't have any type of update to it, but the platform does get a display. So inside our draw, we can say platform, and we can tell it to display. And the cool part, because we've already added that class, or that method to our platform class, when I hit D, it said, hey, I bet you want to use display. I'm like, sure do. Hit return on the keyboard, and it's done typing. Semicolon, close out the line. The fewer characters I type, and the more the computer types, the less errors I will make in the long run. Now if I run this, we should see it come up on screen. Get the player there. Now the player's not moving, the player's not jumping yet. It's moving, but not how I want it to move yet. And my platform is sitting here. I'm going to start the player out somewhere. The player can land on the platform, be able to jump around on screen. fall off the platform and reappear at the top, so we'll do a vertical wrapping with the player. We could do a horizontal wrapping if we want, or we could make it bounce off the sides, but it can only vertically go. Those are niceties that you can investigate as you add more to your project. The next thing we will want to be able to do is we will want to find out, has the player intersected with the platform? And if the player intersects with the platform, then we'll need to make something happen. And once we do that, then we will set about modifying the player's movement so the player moves horizontally but then can jump in the air. And when the player jumps, then the player has the capacity to then land on a platform. But if the player is not on a platform, the player should be subjected to the effects of gravity and fall. And that's what we will then add into it as well. After we look at this, so our intersect is really, it's just like we're doing an intersect, but instead of with the sprite and the enemy, it's going to be with the sprite and the platform. So we'll need to figure that out by grabbing, whoop, too far, grabbing that code. And this time, instead of sprite and enemy, it's going to be sprite and platform. So we're finding out, have these two rectangular objects intersected with each other? And it's going to return a true or false value. So there's no changes that we need to put into this. We don't have to do anything different with it. We get to just leave it as is. Just return false, return true, etc. And this is now where we will then do our if, right? Rectangle intersect, and it'll be our sprite and our platform. So we're asking if they have intersected, and if they have intersected, we want something to happen. And apparently I can't type intersect. All right, so if rectangle intersect sprite and P, so S and P versus S and E, then we want to do something. And this time I will fill the whole universe with yellow instead of filling it with red. We will be ditching these lines with the intersect and changing it in a little bit, but the first step is always to verify that the program is registering what you need it to. Okay, so that intersect happens. Yep. So we can see that the player is properly intersecting, checking left and right boundaries, top, bottom boundary. So we're making sure that intersect is happening. So that's important because we want to make sure that the hit boundaries, the rectangles of intersection, are corresponding with each other and lining up correctly. Now comes the fun part. This is where we're going to tear apart the sprite and rework its guts for movement. We're going to work on modifying the movement of the sprite so the sprite can behave properly for moving. The key thing that we need to do on the sprite is we need to know when the sprite is connected with the platform and when it is not. That's the magic trick that we work with on this. Because when it's intersecting, that's great. And when it's intersecting, we want to then say, hey, guess what? You're connected, so now you're no longer falling. So you won't be subjected to the force of gravity. When you're not connected, then gravity will accelerate you up to whatever speed limit we set. If we don't put a speed limit on gravity, it gets pretty humorous because your sprite starts falling at ridiculous speeds and almost starts to look like it's going upward. It's like watching a spinning wheel that starts to look like it's spinning in reverse once it hits a certain amount of revolution. So it's kind of fun. So we will need to add in a max speed, but we'll do things kind of one step at a time. We need to have our Boolean of connected. We're also going to need an additional float, and this will be for gravity. Now, we could, if multiple things are being affected by gravity, we may want to set gravity at the main level of our program so it's a kind of a universal for everything. Right now, the sprite is the only thing being affected by gravity, so we can just define gravity here. Otherwise, I would want to define gravity inside, at my main program level. All right, so now we've defined gravity. Oh, I don't want to define it. Oh, okay, whatever. Can define it there, but to use our standard method, we'll put it inside the constructor. Now connected. Connected is going to start out at false, meaning we're not going to be standing on a platform, and gravity will be equal to 0.6. So what we're doing is we're adding in a little bit of speed each time, each frame when we're falling. If we don't put a speed limit in, then it starts to fall really fast. So we will discover that we will need one, but again, we'll add it when we get to that point. Okay, left and right, we can leave the core of it, but I find that I want to slide a little bit faster, so I'm going to change it from 2 to 5. We can leave the rest of the left and right stuff there. Now, the part that gets changed as we work through this is we're going to be modifying what happens when I press up. Down is going to be completely disabled, so we're not doing anything with down because I'm either moving left, right, or jumping. I mean, if we could add in a ducking or something, then we would use down. But because we're not using anything with down, I'm just going to take all of that stuff that uses down. So it's either not up and down, is up and is down, or down. Just comment all of that. We don't need that. I mean, I could even just delete it, which I will. You can decide whether to delete it or not. I'm deleting to make room on screen so you can just see more code when we are studying this. Now, when I press up, I want my speed to change in a negative number to a pretty decent negative number, so it looks like I'm jumping. So I'm going to change it to 15. And then once I have done that, so I've changed it to negative 15, then what we are going to do is every frame that we are not connected to a platform, we're going to apply gravity. So we're going to add in that gravity. So negative 15, when I jump, means I move up. But now I apply gravity, which is 0.6, is a positive number, so that it will make my speed going up a little bit less, and then a little bit less, then a little bit less, until eventually it reaches 0, and then it starts to become a positive number again, 0.6 plus 0.6 plus 0.6 plus, and pretty soon I'm accelerating, and I'll get going pretty fast, quickly, and we'll get to see it, and it's kind of fun. So what we can do is just say speed y. Oh, I forgot though. Before we do that, we say we want to find out and say if connected is equal to false. So if I am not connected, then at that point and only that point, what we say speed y gets affected by gravity. So speed y will be affected by gravity when I am not on a platform. because when connected is false. Now, the challenging part you may realize right now, if we run this, there's no possible way for the player to ever be connected yet. Because, yes, we can intersect a platform, but it doesn't change my state from not connected to connected. So I'm just going to keep falling. But I'm going to run it anyway just to see. And we can now, oh, shoot, I fell. And I have no way to get back up because I don't have any wrapping going on. I'm not hitting the bottom, going back to the top. So, yeah, I disappeared. That was kind of sad. I accelerated, but now I'm gone. If we want to do the screen wrap, we can say if my y is greater than height, so that I have now gone off screen. So if I go all the way off screen, at that point, we will say y is now equal to 0. That puts me back up top. Now if I run this again, I'll see that I get looping, and pretty soon we're getting a cool strobing effect as it's moving across the screen. And it's going really, 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 really fast. This is where I want to probably do a couple of different things. I might want to put a speed limit in to prevent me from falling too quickly. That's a good first step. I may also want to modify, because if I'm going at maximum speed and it hit the bottom and go back to the top, I'm really hauling the next time I fall down. So I might want to even negate my speed every time I get to the top and just kill my speed. So we can do that first right here and just say speed y is equal to 0. So if I've run off the bottom, I'll put myself back at the top, kill my speed, so then I can re-accelerate. And now we see it's a little more manageable of a situation to watch. So to land on a platform, we're going to make a method where we can now effectively kill the momentum or speed of our object so that it hits the platform. And I'm just going to call this method land. Now what land will do is land is going to set our speed y equal to 0. Now we have this variable that we've been looking at called connected. Connected is currently false, but when we hit a platform, we want connected to be equal to true. So we want connected to be set equal to true. So then connected will be true. That means it will no longer keep pulling us down by gravity. So let's see what happens. Nothing. Because we wrote the function, but we never called that function. This is one of those things when you're going between your different files, you're like, I do it. Crap, why is it not working? Oh yeah, I have to actually ask it to do that. It's really easy. You're like, I wrote it, so doesn't it know that's what I want? And no, it really doesn't know. So we can just leave the yellow in there. We'll get rid of that. But now I can just say sprite land. So now we find that method. Now let's see how this works. Hey, oh, huh. That's not right. Huh. How's that working? Now we're able to fall when we jump. Gravity no longer applies. So if I go up, what I really need to say is connected is equal to false. So that now kills connected. But you have to spell connected right, not with 3 N's, and only use 2, and then it works better. Okay. Now I jump, connected. So what we can see is our jump is working. It's really bouncy. And oh, look at that. I'm like halfway through the object. That's problematic now too, isn't it? Well, we'll figure that out. You know, because we solve one problem at a time. But you know, it's kind of annoying that, you know, once I leave that platform, you know, gravity's apparently, you know, not working anymore. So we're going to have to figure that out. But if we think about it and go back to the main class and say, so if I intersect, we tell it to land. But the reality is, if I'm not intersecting a platform, that means I'm not connected. And we need to tell it as such. Because when the sprite leaves the platform, the only thing that's aware that it's left the platform is our intersect function here. So we need to now take advantage of the fact that our intersect knows I'm connected. So I say, hey, you know, land on that platform. Else, and in this else, we are going to say s dot connected is equal to false. So then we set it equal to false. And when we do that, now if I go to the side of the platform, gravity affects me once again. I can go up. But now we'll notice if I keep holding the up key, I can kind of bounce it. So I have, if you play, you know, different video games, you get like double jump, triple jump, and cool, you know, things like that. Apparently I have unlimited jump, which would be really cool in some games because then you could really cover a lot of distance on a map. But yeah, and we're falling through the platform still. So we got two issues that we need to address to round out our platform conundrum. And I do like how the red and yellow are now making orange. That's kind of cool. That's part of it. So as we look at these two items that are affecting it, one is that we're going down too far. So when I intersect the platform, what I could do is I could tell the sprite, I could say, hey, how about I tell you where this platform's top edge is? And if you know where that is, you can position yourself so that you are not going into the platform, but sit on top of the platform. So we'll pass in that information. So when the sprite lands on the platform, what we can do is we can now send the sprite the y of the platform, remembering that the y will be then that top edge. So we're sending it that data. And then we need to modify the sprite's land function to receive that, because it will be looking for that information. So inside the sprite here, we can see land. Now it would be a float. And I will just call this my destination y. And now we set the y value of our sprite. We're going to set that equal to the y value of our platform. Let's see how that works. Oh, close. So if I land, oh, look at that. Well, I landed on it. I landed on it. Oh, come back down. Oh, but look at, our y's are the same. So I need to adjust this destination by the height of the sprite as well. So dest y minus the height of the sprite. And then when I do that and land on the platform, I get to sit on top of it. Boy, now I'm sitting on it. And we still have to take care of this double, triple, quadruple, infinite jumping capacity. By limiting my upward movement to only when I am connected. So if I press up and I am connected, or connected is equal to true, both ways would be okay to write it, Then I adjust my speed up and reset my connected to false. So now if I run it, land on it, jump, now I only get a single jump. So now I'm hopping like a bunny rabbit. The next step at this point would be to add in multiple platforms. And then once I have multiple platforms, if I have enough of them, I just put them in an array, and then I loop through the array to see if I'm connecting any of them and work with it. Because the cool part that we can do with this is only stopping me when I hit it from the top. So I can actually jump from the bottom and jump through the platforms. It's possible to set up the collision so that I can't go through boxes and have to go around them and do that style of platform jumping as well, but that's not what this code does. This code allows me to jump through the box on it. To add multiple platforms to this, the best way to manage that would be to create an array of platforms. So then I would just specify it as platform brackets and then say platforms, and I'll call my array platforms. Now platforms is equal to a new platform object that goes into my array, which is going to have 2 platforms. You can add more platforms as you see fit. I'm just doing 2 because that's all I am interested in doing at the moment. Now, for building platforms, typically we're not going to have more than maybe half a dozen, and each one will be specifically placed. So if we think back to particles, or if we think back to the drops where we had multiple objects where we used a for loop to populate the array, that doesn't work really well here unless they're all going to be like staggered by some numerical formula. But because we're going to be very specifically placing them on screen, we really are just going to want to designate it by saying platform 0 is equal to, and then I will use the first one that I have here, copy that, paste it in. And I will be commenting out all of my single platform code in a little bit once we have this part in. And now we can say platforms 1, and I will put it at the same X location, but I will put it up a little bit. I'll put it at, say, 400, because the first one's up 100 from the bottom, so we're just staggering them up. Okay, so now I have 2 platforms. And now I'm going to comment out my original platform. Items there. Oh, forgot my S's. Okay. But for displaying the platforms, at that point, we could use a for loop. So we do the for int I equals 0, semicolon I is less than platforms.length, semicolon I plus plus, close parenthesis, throw in a couple curly braces, and then we say platforms, square bracket I, square bracket, dot display. And then that tells our 2 platforms to display. Now before I worry about the intersection of the platforms with it, I want to verify that what I have here is indeed working and that I do have 2 platforms showing up on screen. As always, code a little bit, test a lot of it. That sounds really stupid. Code a little, test frequently. And now we can see, okay, I have 2 platforms there. But now I took away the intersect, so they're not intersecting on themselves yet. But the intersect that we'll be working with is going to be that code. So I'll copy that. After I tell the platforms to display, then I'm going to verify or check, have my platforms intersected. But instead of sending it P, it's platforms, square bracket I square. So we have to specify which element. So everywhere that we were using P, we now can just say platforms, square brackets, I. And I don't need it to turn yellow anymore. I'm just going to kill that. I don't like that. So if I cycle through this, tell the platform to display, then I find out if the platform has intersected. If so, I tell the sprite to land on it. Otherwise, I tell the sprite, you're not connected. Now if we run this, you can see, oh, okay, I'm going to have to stagger them because I can't even get to the bottom one. Oh, hey, look, I made it through. This working, we're going to go through the platforms twice. Once just to display them, and once to handle the intersections with them. So I can jump, land on it, jump, land on it, jump through. Whee! Now we can land on multiple platforms, and if you want to add more and more platforms into your project, change the 2 to a 3. I'm going to offset these by 100, and then I'll have a third one. This will be platform number 2, and it will be at 100, 300. So now I have 3 platforms. We can see land on one, land on the next, jump, jump. So now we can go. Now if you find things are being snappier than you want, or going higher than you want, what we can do is we can modify your speeds. So if it's jumping too high, maybe you need to slow it down to 10. Oh, funny. And the enemy is parked there. So I'm still colliding even though we're not seeing them. All right, and now we have a platformer.